Hi, this video is about designing your first rocket into RockSim. Now, this is kind of the rocket that I'm going to design, and it helps to have the rocket available that you're designing. So the first thing I would suggest is designing on a piece of paper. Just draw a sketch of the rocket so that you can kind of gauge part size and location. The hardest thing about designing a rocket is finding out the names of parts and what size they are and what two parts go together like this. That is the hardest part about designing rockets, and if you can get over that hurdle, it's going to be easy. I recommend that you have a ruler available, and when you're measuring diameters on things, I recommend using a caliper like this. This is a digital caliper. They're available at hardware stores. They're fairly cheap. I got this one at what's the name of that store? Whatever it is. Yeah, to use them, I'm doing this upside down for you. You can see it's digital, and it's I'm in inches, and so you just put it around the item that you want to measure, and then just squeeze down gently on it. And if you can still rotate it in there, that's pretty good. You don't want to squeeze so tight that you can't rotate it, because then the numbers change. And then it gives you an accurate measurement of the diameter of the item you're measuring. This side is used to measure the inside of tubes. So what I would do is I would stick the two prongs inside and then gently pull it outwards. And again, you got to be able to rotate it, because if you pull too hard, you're going to turn the tube into an oval shape like that. And that's not what we want. We want it to be nice and round. So just gently pull it in, and you can measure the inside diameter like that. That's how you use them. You want to be able to measure parts. Same thing on, if you're measuring the tip of a fin, you could measure it like that. To measure the span of a fin, you've got this piece right here that comes out, and that allows you to measure depth. So what I would do is I would push it up against the tube like that, and then squeeze down so that this part right here on the caliper touches the edge of the fin. And so now I'm measuring this length, and it tells you what that length is over here. So very cool, very simple, easy to use. Get one of these if you're going to design a lot of rockets. I wouldn't know how to design a rocket if it wasn't for being able to measure components accurately. The more accurate that you can measure them, the better your rocket's going to be in RockSim, the more accurate the simulations will be. So now I got RockSim running. If there's anything on your screen, hit the new file button, and that will clear out anything. If there's something there, it'll ask you to save whatever the old thing is. So now I'm starting with a blank screen. And I hope you watched the previous videos on how to use RockSim, because it tells you how to get around, how to change things so that everything looks proper and in its place. So as I said before in a previous video, when you're designing a rocket, you move along these tabs here at the top of the screen from the left side to the right side. So we start with the design attributes. This is where we're going to give you the rocket's name and how the simulation is performed, how many stages are in the rocket, that type of thing. So I'm going to say my first rocket. And the CP location, by default, it's under RockSim, so I would leave that. This is a single stage rocket, so it's only one stage, so that's all we need to worry about. And the static margin reference, I'm just going to leave it at the base of the nose cone. Okay, so I'm done with this tab. Now I'm going to go over to the next one. Oh, let me say, there's this more button here under rocket name. This is where you get to promote yourself. So if you share your design with somebody, they can see who did it. So then you put your rocket designer name in there. Can't spell my own name. You can put comments and what changed from the previous version if you have a previous version. all that information can be stored in there. And that's stored with the design, and other people can look at it if you share your designs with others. Our next tab is the Rocket Design Components tab, and this is where we're going to start to add parts into the design. Since this is a single stage rocket, we call a single stage rocket just the sustainer. And we're going to start to add parts into the sustainer. And when we do it, we work from the top of the nose all the way down to the bottom. So the first part we're going to be in is the nose cone, then the tube, then the fins. And that's probably all we're going to get through in this video. And in the next video, I'll show you about adding the parts that are on the inside of the rocket. So over here on the side, we see these are the parts that RockSim is allowing us to start with. And we're going to start with the nose cone. Now, if you're designing from rocket components that you bought from somebody else, like this nose cone is an Apogee nose cone, we try to put them in the database, but we are not the manufacturer of other manufacturers' items. So if you've got an XYZ company's nose cone, don't come asking Apogee about the size of those parts. They're on their website, so go to their website. If it's an Apogee nose cone, it's in here, and we will try to put those in here. So if I go to the Apogee website, I've already brought this item up. This is a PNC 33, and you can see it on our website. Yeah, that looks to be the same nose cone here on the screen as here in real life. And then I want to look at this part number, so it has a part number 20068. So when I go into RockSim, I can sort and look through the part numbers. So I'm going down here to the Apogee part numbers, and then I'm going across to the part number. And this is the 68. So I can just grab it from the database. And that's the easiest thing to do, just grabbing an item from the database. But now you have the option of tweaking things. And if you were designing from scratch, you would have to start measuring. So you would measure the length of the nose cone, like I'm doing here, and then you'd measure the diameter. And you can change these in RockSim. First, we have the shape of the nose. And this is an ogive, but you can change the shapes. Don't be afraid to change things and experiment to see what buttons do. So if I change to parabolic, watch the shape of the nose cone change. Okay, and then you can compare this to what's in real life, and if it doesn't look right, change it to something else. So this is the elliptical, and as we said, I know it's an ogive nose cone because it actually says that on the Apogee website. So I'm going back to ogive nose cone. So this has the length, the diameter, and then the base length. The base length is if it turns into a cylinder. So how long would that cylinder be before the nose cone actually started? Most nose cones don't have a base length, so you don't typically have to worry about it. One of the most important things when you're designing a rocket is choosing the right material, because if you don't choose the right material, RockSim is going to do weird things when you try to launch the rocket and run a simulation. So make sure you're selecting a material from the list. You can add materials later, but for right now, I know this is a high-impact polystyrene nose cone, so that's the material I'm choosing. And the construction, this is a hollow nose cone. If you look inside, you can tell it's hollow. And then when you're first starting out, you're not going to be able to measure the wall thickness. There's no way I can get anywhere in here to find out how thick this plastic is. So we're guessing at this point. And the guess that we're going to get is going to prove that we guessed the right, we look at the component mass. So right now, at the guess that we have in here, it says that this nose cone should be about 14.103 grams. So get your gram scale, measure it. If it's not the right thickness, you want to adjust, or if it's not the right weight, adjust that wall thickness. There is a tab over here called Mass Override. Sometimes people check this by accident, And then when they change that wall thickness and it doesn't change the calculated component mass down here, that's the issue, is that you have this little check box checked that says use the mass and CG information below. That's right here. That is if you want to override the mass of the nose cone. So right now it's unchecked, so RockSim is calculating it, and it's using this wall thickness. And if I go to the Apogee website again, I can compare that. It says that the weight should be about 18.6, so that tells me my wall thickness is too thin. So if I go back to RockSim and I change this wall thickness to 0.05 and hit tab and see what happens. Now I'm at 17.4, so I'm real close. I'm probably if I go to 0.06, it's going to be too heavy, so maybe I'll go 0.055 and hit tab, and now we're at 19, so now I'm too heavy, so it's under 0.055. I'm going to guess 0.053, and you can see I'm 18.3, so I'm pretty close. I'm happy with that, and I'm going to leave it. The next thing we have in these tabs here along the top is the shoulder. The database is what we saw earlier, picking parts from a database. You can always go back to the database, and that's where this is. You can say choose from database, and it brings up the database again. I'm just going to cancel out of it. You can create a nose cone and then save it into the database, and that's what this Save to Database button is. It'll add it to your personal database on your machine. The shoulder tab is the shoulder, which is the part of the nose cone that slides into the tube. So again, you can measure the length and measure the diameter of that. Since I've chosen this from the database, I know it's pretty good. The mass override tab we talked about, this is if you want to get really precise, or if it's an odd item that doesn't have a weird, its shape is a little bit weird. You can use this to override what RockSim wants to calculate it as based on the material and the density of the material and the geometry of the shape. It's calculating the volume, and from that volume it multiplies it by the density to come up with a weight. So the mass override overrides. It says don't use what RockSim has, override it, use what I'm actually measuring. So for this nose cone, I'm just going to leave it alone. Just let RockSim calculate it. Color. This is, I can tell when people are trying to do things really fast because they leave the colors as the default. And the default color is a blue color. So if you send me a RockSim file and it's blue, I know you're cheating. I know you're just trying to get it in there as fast as possible because most people like to change the color of their rocket because that's the visual aspect of rocketry, that everybody wants to make a rocket that's unique and different. And if yours is blue, I can tell you're just trying to go through really quick. So I'm going to change the color here, and I'm going to make it that color. It doesn't matter. You can change the colors to anything you want. And I'm going to change the 3D color because RockSim has a 2D color and a 3D color. So if I say, hey, let's make it a red nose cone. So even though they're both kind of red right now, they're different shades of red. And if I go to 3D, it shows this nose cone in this red here that I've picked. Okay, so now we've got our nose cone, and if you like it, you can click the OK button down here at the bottom, and now it's part of the design. You can see it's been added to the tree right here. Now we're going to add the next part into the design. So I need to make sure that the nose cone is highlighted because I'm going to attach this nose to something else, and it's going to be attached to this tube. So this tube is next. So highlighting the nose cone allows me to select body tube. Now there's two tubes. There's an inside tube and a regular body tube. Since this is on the outside of the rocket, it's a regular body tube. So go ahead and click that, and it's going to bring up the database again because it always tries to look in the database first. If you want to make it a custom body tube, just click cancel. You also have the option of always displaying this, and that's this little box back down here. I always display them because I always select from the list because it's just easier and faster for me to design rockets that way. Again, we want to go and find the part number of the tube. I already know this is a 33 millimeter nose tube, so I'm just going to select that one there. And it adds it into the design. And by default, it sets the tube length to 18 inches. That's just an arbitrary length. It doesn't mean anything at this point, but now you need to actually change it. And you can see it also set the diameters, the outside diameter and the inside diameter based on what was in the database. If it's not in the database, you're going to have to measure it. The length, I know this is an 18-inch long ruler. And I can tell already just by looking at it that this is not an 18-inch long tube. So we'll go ahead and measure it. And I'm at 13 3/4, so 13.75 inches. So I can either use this slider bar right here to change the length, or I can actually type in the number 13.75, hit tab, and it jumps it. That enters it into the design, and so now my tube is in there. Again, let's change the color. I'll make it a green color. The 2D color is not so critical. The 3D color is what it's going to look like later. So you might want to have more thought into choosing the 3D color than the 2D color. Whenever I do a nose cone and a body tube, then the color is it's going to be the same. So if I'm going to paint the whole thing red, I tweak one of the two in RockSim just slightly so I can tell where the dividing line is on the nose cone and the body tube. So I'll usually go here, just tweak it just a little bit, and you'll see it in the 3D view of the rocket. And I can actually see that right now. So if I zoom in here, I can see the dividing line where the nose stops and the tube starts. So that's my little personal trick. Okay, so now I got my tube in there. Our next thing is we're going to need to add the fins. So the fins, we need to make some measurements. Now there's three different kinds of fins in RockSim. There's trapezoid and elliptical fins, and that's this button right here. Then there's custom fins. If it's not a trapezoid, not an ellipse, but it's flat, then you're going to choose custom fin. And then the third and the fourth type are ringtails and tube fins. So a tube fin is, you think of another tube like this strapped to the side. And that can be a fin. It does work. So that's called a tube fin. Now a ringtail is different. A ringtail is a whole ring around the outside of the rocket tube. So in this particular case, this is easy. This is a trapezoid. So I'm just going to go to just regular fins and just click on that. And again, it brings up the database. This time I'm not selecting from the database. I'm going to do one from scratch. So I'll click cancel there. And let me resize this window so you can see what I'm doing. Every component has a design window. Each design window is customizable in size. I showed you this in a previous video. You can change the sizes of these windows. Okay, so by default, RockSim throws an arbitrary fin on the rocket. So even though it looks similar, what's on the screen and what's in real life, we need to modify what's on the screen to what we have here. So we're going to call this a fin set. So then the first thing is you have to choose the number of fins, and you can choose anywhere from 1 to 8 fins. In a fin set, you can have multiple fin sets. So if you have 15 rocket fins around your tube, you would do it in 2 stages. You would do one with an 8 and then another one with a 7, and change the radial position to get them to all line up the way you want it. You can do some really complex things with RockSim. Right now we're just doing something very simple. So now we need a root cord. Now the root cord is the part of the fin that attaches to the tube. So I'm going to measure it here. I'm trying to do this upside down so you can see my caliper here. So this is 2.456, so you can round it off to 2.5 inches. Probably that's what it started as before you started sanding things down. So the root chord, 2.5 inches. Then our tip chord, again, we're going to measure this. 1.43 inches. Hit tab. The next, I'm going to skip sweep length and sweep angle. I'm going to go right to semi-span. Semi-span is the distance that it projects out from the tube. And I showed you this before with the caliper. You take it, you always start long, and then you kind of bring it into the item that you're trying to measure. And that's at 2.455 inches. Okay, so now we have the outside, but now we need to know how far back this tip is from the tube. And there's two ways to do it. One is angle, and one is measuring distance. So if I was measuring distance, it's this distance from this here to the ruler. You know, if this ruler is absolutely perpendicular. The other way is measuring it with an angle. This is a little bit hard to measure. You know, you're going to have to do a little bit more math, or, you know, drawing things out on paper and measuring it with a protractor. You can do it that way. I'm just kind of eyeballing it right now. You can see I got one end of the caliper up against the ruler, and then the other end is right here, and I'm trying to match that. And I'm doing it upside down. Okay, so I'm gonna call that 0.385 inches, and that's the sweep length. Now you can changing one or changing the other. Look, you can see the sweep length and the sweep angle are changing as I move either of these slider bars. Or you can type in a number, which I just did, 0.385 inches. Okay, and that doesn't quite look right, so I'm going to tweak it a little bit. You can also put your cursor on the slider bar and then use the number or the arrow keys on your keyboard to fine-tune it a little bit. So I'm fine-tuning it like here, and it says it's 0.625. So I'm like way off on measuring. Not sure what's going on there. Again, check the material. Make sure this is where the people that send us designs are always where they always, the component they always screw up is the fins. For some reason, they never select the material of the fins. They're so fixated on the shape that they forget about the material. So don't forget about your material. So right now we have balsa wood. And then the thickness here is 0.125 inches. And again, you can use your caliper to measure the thickness of the wood. And that's pretty close, 1.125. And this is 1/8 inch balsa wood. Okay, and we're going to also change our color. Right now I got, I'll go with a blue fin in, well, I don't like to have my 2Ds as blue because blue is the default. But my 3D color, I'll make that one blue. All right, so now let's look at the rocket in 3D. And there we have it. And we can rotate it around, see inside. And it's looking pretty good. Oh, the other thing that is different here is these fins aren't on the very end of the tube. You can see I got a little gap here. So that is under the general position, and that's the location. Right now the fins are measured from the tip of the tube, and we want to change that to the base of the part. So now I'm going to measure from here to here, and with my ruler I can eyeball that. That's 1/2 inch. So from the base it's 0.5 inches, and you can see, let me go back to 2D so it's a little easier. You can see it's now moved forward. You can have these as negative numbers if you want, so your fins hang off the back of the rocket, and that is perfectly acceptable in RockSim. Okay, so if I like my design, I'll click OK. So now we have a basic shape of a rocket, and in our next video we're going to put the stuff on the inside. But before we do that, make sure you save your design so that if you lose power on your computer, you have it saved. And I'm going to call it My Design. And hit Save. Okay, the design is saved, and we'll see you in the next video, and we'll start putting stuff on the inside of this rocket.